Substitution, the method is you choose u. You take a derivative, and then you solve for dx. Dx goes in here, and this guy gets replaced with u. And what you've done is you've done a change of variables, we say. Okay. In terms of x, the integral is awful, but in terms of u, it is much nicer. Okie dokie. Let's do another example before I present the recipe. Okie dokie. What do we got here? Okie dokie. Oh, okay. X squared over square root x cubed minus 1. X cubed. Okay. My inside function is x cubed minus 1. Okay, in some sense, just x cubed is an inside function, but I'm gonna, as a rule of thumb, you should be maximal in your choice of u. Okay, so choose the entire inside function. So x cubed minus 1 is inside this square root function. Okay, do a derivative. Du dx is 3x squared. And then I'll solve for dx. I get du over 3x squared. Okay, basically the dx and the 3x squared switch positions. Okay, so I have my u here, I got my dx here. I plug them back in and hope for the best. Okay, what I'm hoping is that all of my x's disappear. If your x's do not disappear from this stage, then you have a problem. Not always insurmountable, but a problem nonetheless. Okay, x squared, cancel, cancel. That 3 will move out front as a third. I got 1 over root u. That's u to the negative a half. Let's put that in a thought bubble. Thought cloud. So what's left inside is u to the negative a half du. And why do I want u to the minus a half? Well, it's because I want to use power rule. So what I got u to the plus a half over a half. Okay, it's plus a half here because I've added 1 to negative a half. So what do I get? 2/3 u to the half, which is 2/3. Put my u back in. What is my u? I have forgotten. What is my u? I have no idea. X cubed minus 1 to the 1/2. And plus a constant. And there you go. I believe that's correct. Let's just double check my notes. Yes. Okay, you'll notice I use the half. If you want to make this a square root, that's okay. Or you can leave it as a half. Does not bother me.